So in this lecture, let us see how to find the limit of eccentricity for the condition that no tension to develop. In case if in a section we want no tensile stress, then what should be the limit of eccentricity? So that is the discussion here. We very well know that the maximum stress is given by direct stress plus bending stress. Direct stress is P by A, bending stress is M divided by Z. And minimum stress is direct stress minus bending stress. So let us take this here. Say, this is bending stress. So if this bending stress is greater than this direct stress, then you will naturally result in with negative stress or tensile stress. That is mentioned here. If the bending stress M by Z is greater than the direct stress, then tensile stress will come into play. That is, normally we used to have a minus as tensile stress in case of columns, because columns is predominantly a compression member. So in a compression member, compression is positive and tension is negative. So if you get minus, then it indicates tensile stress. So for no tension to develop, this bending stress should be less than or equal to direct stress. That is, M by Z should be less than or equal to P by A. This is the condition required for no tension to develop in a section. So having this, so we know that M is equal to P into E, load into eccentricity, divided by Z. Z is the section modulus. Should be less than or equal to P by A. So P will get cancelled, and therefore E, the eccentricity, should be less than or equal to Z divided by A for no tension to develop. So let us arrive this eccentricity value, limit of eccentricity value for various sections. Let us take a rectangular section as the first section. So we have a rectangle of width B, depth D. This is x-axis axis and this y axis. So when we speak about eccentricity with respect to both the axes, we will be requiring this extreme fiber distance also. So the extreme fiber distance from the y axis, let us name it as x, and the extreme fiber distance from the x axis will name it as y. So we very well know that x should be equal to this b by 2, and y should be equal to d by 2. Okay, then the eccentricity should be less than or equal to zxx divided by a, as well the eccentricity should be less than or equal to zyy divided by a. That is, with respect to both the axes, we should find the limit of eccentricity. So zxx equal to ixx divided by y. So ixx is moment of inertia about x axis will be b d cube by 12 in case of rectangle, and y, the extreme fiber distance we see here, y equal to d by 2. Therefore, this will result in bd squared by 6. So the section modulus of a rectangular section with respect to x-axis bd squared by 6, and naturally with respect to y it will be, or it would yield db squared by 6, like this. That is iyy divided by x. Iyy is db cube by 12 and x is d by 2. So it will be db squared by 6. We know that area is equal to b into d. So if you use this, then eccentricity should be less than or equal to zxx divided by a. That is, it should be less than or equal to zxx is bd squared by 6 divided by bd. Therefore, the eccentricity should be less than or equal to d by 6. Similarly, E should be less than or equal to zyy by a. So E should be less than or equal to zyy is db squared by 6, we have already here, divided by bd. Therefore, b by 6. Eccentricity should be less than or equal to b by 6. So let us plot this in a rectangular section. So this is x axis and this is y axis. So with respect to x axis, the limit of eccentricity is d by 6 on either side. So here d by 6, here d by 6. So mark d by 6 on either side of the x axis. Similarly, with respect to y axis, mark b by 6 on either side of the y axis. So we'll be getting 4 points. Connecting these 4 points, what we get is called the core or kern of the section. We call this as kern or core of the section. So the logic reason behind this is, when we apply the load within this core, anywhere in the core, then we will not result in with tensile stress. This is the principle behind it. So the core or kern of section will allow us to decide the limit of eccentricity in a better way. So here if you mark, say this is d by 6, d by 6, and this is b by 3, b by 6, b by 6. Therefore, the width of the core, this is the width of the core. The width of the core will be equal to b by 6, b plus b by 6. Therefore, it will be b by 3. And the depth of this core will be d by 6 plus d by 6 will be d by 3. So, if the load is applied anywhere in the kern or core of a rectangle section, there will not be any tensile stress. Okay. So, this is the core or kern. With this, we can also define the middle third rule. Say, if we divide a rectangle into 3 portions, say along this y-axis, similarly along x-axis, then this region is the middle third with respect to y-axis as well. This will be the middle region with respect to x-axis. So this we call as the middle third. So if the load is applied within the middle third of any section, then there will not be any tensile stress. This middle third rule will be very well useful for finding the stability of a dam. Now we'll move to circular section. So in case of circular section, we have x-axis and y-axis. So ixx equal to iyy in this case, that will be equal to pi d power 4 by 64. And we know that eccentricity should be less than or equal to z by a, z equal to ixx divided by y, or iyy divided by x. Both will be same in this case of symmetrical sections. So pi d power 4 by 64 divided by this y or x will be equal to, see y as well x will be equal to diameter divided by 2, d by 2. Therefore, pi d cube by 32 will be the section modulus of a circular section. So, pi d cube by 32 divided by area is pi d squared by 4. We'll be getting eccentricity should be less than or equal to d by 8. So, if we mark in this diagram, so let us keep d by 8, similarly this side d by 8, we'll be getting 4 points. We form a circle, and that will be the core or kern of the circular section. So, if the load is applied anywhere in this core or kern, we will not get any tensile stress. And the diameter of this core will be equal to this d by 8 plus d by 8, therefore d by 4. d by 4 will be the diameter of the core. So, thank you for watching our video. Kindly subscribe our channel to make it reach everyone and have the habit of learn easy principle.